are live.
We are live after a slightly false start where we thought we were live and we talked for about 2 minutes and then realized actually we were not live. So yes, welcome everybody to the latest live that we're doing here at HORAGE. And this one is a big one. Well, the clue's in the name.
Right.
It's a mega update. We are something that many of people have been waiting for, not least the 300 people that have put pre-orders in for the Revolution 3 MicroReg watch. But it's more than that. It's going to be all about everything that's been going on since almost the start, right up to today, including at the end, we will do the important things, which is talking about when deliveries should commence and giving you a bit of an idea of hopefully when you should start to see your shipping notifications. But before we get to that bit, we've got lots of stuff to cover. And I should introduce that we've got two guests on the show. We have Sylvan. Say hello, Sylvan.
Hello.
There we go. Sylvan, you may have seen Sylvan on the last live when he was talking all about the Tourbillon project, but he's also one of the leads with the MicroReg project. And we also have Marcus. Say hello, Marcus.
Hello.
Oh, it's disappointed me when I say hello, Marcus. You're meant to say hello, Marcus, but you didn't do that. But Marcus is one of the brains of the operation when it comes to engineering. He is our toolbox of how to fix things that we have no idea what actually needs to be fixed, but he is always the one that, well, typically gets an answer and finds someone or himself to fix it. But they're going to be here to keep, well, myself and Andy in check when it comes to factually correct answers. And Andy's going to be the man of many fingers and hands, controlling way too many screens as usual.
Please forgive me when things go wrong with all the tech today, because we have a lot of stuff going on a lot of screens and a lot of things at the same time to manage. And up front, I wanted to say, when making this presentation, by the way, I recognized how damn good our team is. I have to say this, I mean, this is insane what we are doing. This guy, me, coming up with some stupid idea, and then there are a lot of pretty smart people who can make that happen. And I want to have that said.
I think that is a very pertinent point to make. And alongside that, we have got new people in the team that were not part of anything we've done before. The guys, of course, from the guys that invented the MicroReg technology or the actuator themselves, the guys from Miniswys. They have, well, brought new learnings to all of us because we're working in software, we're working in other areas that, well, traditionally you've never been worked on within watches. So yes, lots of things going on. So Andy, we should probably move to the first slide because we have got a serious amount of stuff to get caught up with over this one.
So first slide.
So this is stuff we're going to talk about.
I'm going to explain a little bit. Yeah, we are having some things to talk about. I will switch into a little bit of a bigger screen. So
let's go full screen.
Down a little bit. Yeah, so we are talking about several different applications, and I thought about what are the key points. So we have the field of the watch, we have the field of the movement, we have the field of actuation, we have the device itself, which is a 3D printed device, which inside of this device there's a motor controller, and we have a ton of software which actually pretty much asks the customer, what do you want to do, and tells the device what it should do in order to do this adjustment. So it's massive amount of it's a massive amount of work which goes in there, and FTEs. Not everybody is familiar with that business talk. Full-time equivalents. So I was just guessing or counting quickly how many people are involved in all of these things. So 4 people at least are involved in the watch side of things. 6 people, I assume, from our production team are involved into the movement side of things. I would say 3 people, and this is mainly Miniswys and Lab, are involved in the actuation side of things. Then 2 people, mainly Sylvan, is spent his majority of the time in the device side of things. And then motor control is such a very specific field, but we also do that, specifically Ben and Francesco. And then we have 8 people involved in the application side of things. So that's a lot of people doing a lot of work. It's the majority of our company spending time solving a lot of problems. And I mean, problems doesn't mean stuff is deadly. Yeah, it's a daily job to solve all these problems and try to find solutions for all these kind of things. Yeah.
And I think it's fair to say, if you look at that, you've got 6 different areas, of which 2 are very familiar to HORAGE, the watch and the movement, of course. But the other 4, except for the application, certainly the 3 being the actuation, the device, and the motor controller, they're all new to most of us at HORAGE. The software or the application, we have some history there because we do have some software of our own, but the software specifically for this, again, is all new. So huge portions of what we're doing here is all new to many people in the team. So that also goes to underline what a big task it is involved in bringing this to life.
Shall we walk through step by step?
We should.
When we show real, I mean, we also should look at real watches. Don't be surprised. The real watches we have under that camera are samples, and samples from all versions, because we are using these to do the tests, to do all the kind of stuff. And what we show on the screen are actually the things we are waiting for, the products for series production. So don't be surprised that you see discs like that and discs like that and cutout like that, but we need to test all the stuff and use everything we have to, even some rubber strap here, that's the thing.
I think it's fair for us to say, towards the end, we'll sum up all the things. You'll see lots of different versions. Like as Andy's showing now, there's a watch there with the kind of gold disc. That was the middle disc option that we were playing with, which has now been changed to a different color, a dark anthracite. There's various other little aspects of the watch. But we'll round up towards the end a kind of definitive line of everything that's in production. So as Andy says, just don't take everything you see as that's how it will be finally, but it gives you a good idea of lots of the different tweaks and changes in the development along the way. So let's go through these things.
I'm just showing watches because we learned that the algorithm, when there's a watch on the screen, is bringing more people into the stream. That's what I learned. So thank you.
Yeah, the algorithm likes the algorithm likes real things. It likes real things. So we like to show watches. I have to
say, I'm not very happy with the camera which is on top there, because it just doesn't show the color as it is.
It is a difficult color to show. Because it's not even always the same. If you have them side by side, you can make
everything looks
colors
different constantly. Yeah, but we will change cameras when we have more time for that. Okay, let's go back to presentation mode. So one of the things which has been decided by our big boss is, and by Silvan, because of various reasons, is that we are sticking with a gray anthracite disc, white print. And the difference is, which you easily can see, and Dave's head should go to the right side of his thing, and Marcus a little bit that side.
Other right, Marcus, other right.
Yeah, there's a much bigger yellow triangle in order to guide the eye to see that. And it's because Andi Fesel has a problem with seeing red, So before it was red. And then I said, I'm sorry, but people who have a problem with green and red have a problem to read that triangle. And then after some heavy discussion with my wife, and then we obviously could agree that it's probably better to use yellow. And having said that, it makes also more sense to have a contrasting disc underneath. Silvan, do you have anything to say to that?
To the color, we decided as well to keep it gray, because on the back side we wanted to have for sure gray, and we tested that bicolor, that we have gold in the front side and gray in the back side. But this disc is such a not so easy part to produce, because it's thin and big and gets bent and so on, and we wanted to keep it as simple as possible. So we changed to all gray. To one color.
Brings me right away to the troublemaker disc. So having said that, our job is the fastest and safest way to your wrist. Yeah, that's the job we have. We are not here to do risky stuff, and we understand a little bit about manufacturing. So it is very important to have a very sharp eye on what is good to do, what is good to handle, because that's the first watch of its kind. It's a lot of work, and we cannot afford having risky stuff involved in manufacturing. And one of these risky things is this, and I'm just showing that, is this disc in the back. We didn't really expect that there's an issue, but as you see on this structure, and everything has an influence, the plating has an influence, the laser has an influence, the structure of the part has an influence. And what we figured out, or Silvan figured that out, was that we have a slightly twisted disc. And a big disc, which is a little bit twisted, and this line should demonstrate that it should be flat, but we saw something like that, like a twisted angle.
A wobble.
A potato chip, in other words. And potato chips don't fit so well into a very narrow space where it needs to rotate. So then we were all pretty nervous, and then Silvan actually made up his mind, and Marcus and everybody trying to figure out, could we actually reduce stress by using different structures to reduce this part, then less processing, gold and dual pre-color plate adds another issue, then laser adds another issue, finishing and visible flaws in the surface finishing and these kind of things. So super tricky. And it's basically up to Silvan finally to decide what will be chosen and how we do it.
Yeah, it's currently in printing. So as soon as it comes back, it should be in, I would say, in a week, something like this.
So you make the final decision,
we can make the final decision, but it will be either the reduced or the nearly no twisting one.
Nearly no twisting, okay. So it's amazing. What was the twists roughly up to 0. What did you see?
0.3, 0.4. So way too much.
Too much. Way too much for getting around there. And that's actually probably in the diameter, in the radius of 0.2, and that's too much for the gap. And I mean, we all know that discs are a problem, that they are challenging. Whenever there's a disc in a watch, then you can actually predict trouble. But we wanted it to have like this, and once in our lifetime, we should make a disc to learn something about that. And but I think this is a problem which is solved and can be solved. And we don't need to worry on that. We worried a little bit, So
said with confidence there, Silvan.
Yeah.
It is
another
solved.
thing which we work together. We'll get to your question. So seal design and material. This was something which was very early on a thing. Why is that so tricky? I mean, the first thing you might think, okay, let's make a plastic thing and put that in there. No, the world doesn't work like that, because plastic usually is not very dewy. I mean, you need some sort of long-term flexibility in the material. Making specific ceramic braced connectors would also have been possible, but we are too early in this phase in order to invest into heavy toolings for something like this. So we basically used the same material like on the seal of the glass, which is a proven sealant, hardware sealant, and made these and also redesigned this whole construction here. So there's a lot going on here, and we want to have that waterproof, even if it's a static. Waterproof is one thing, but waterproof and isolated is the other thing. So,
and it's worth pointing out what that part is. That's the part on the watch that allows the tool to have a kind of earthing point against the side of the case. So it has to be isolated from the rest of the case. So it has to be completely disparate. It can't have any transference through it as well. So the material itself can't be conductive, and it has to be flexible and malleable enough to be completely waterproof. So it was a fairly significant challenge. And I know, Silvan, that was something that was worked on for a long time. We could easily have said, well, do you know what, guys? The waterproof rating of this watch is just very low. but a huge amount of effort went in to maintain a reasonable, really good daily usable waterproof rating on this watch so that the watch can be used as an everyday watch.
Use it. Otherwise, I wouldn't wear it.
Correct. And Andy
Because
would
it
have
need
wrecked it
to-
instantly in the snow.
Correct. So, yeah, that's another thing which I think we have off the table, and we are happy with that. Or choose the wrong way. I need to move Dave a little bit to the left.
Oh, Dave's moving magically.
Okay, so next slide. You didn't give me the numbers, Markus.
I did.
Where did you give
In
them to
WhatsApp.
me? Okay, then can you, okay, Mark, can you continue talking a little bit, Dave?
Yes, what can we talk about? Well, one of the questions someone's asked is about software, and it's about APIs with regards to the app, etc. So that's something that we will get to. We're not ignoring your question. We'll get to that a little bit further down the line. It's a legitimate question, and we will definitely get to that one. I'm excited for any other questions that anyone else can put into this chat, if they can do that as well, because, you know, we're here and we want to answer it. And we've also got, you know, two of the bigger brains of the operation when it comes to much of the work that's been done. On this one, Sylvan, you know, this little kind of earthing or neutral point on the case, it's one of these things that is a tiny detail in terms of the watch, but this one took up a considerable amount of time.
Is isolated pin?
Yeah.
Yeah. We made at least 3 or 4 different versions to try to get that waterproof. Yeah, and at the end we found a solution which now works pretty good. Or yeah,
I have
works
corrected,
well.
by the way, my mistake.
Excellent. So we can move on. Dave and Sylvan bridged the gap.
The filler.
we're the fluff in the pudding. So yes,
good.
Here we go.
Just to give everybody a little bit of an idea what we are talking about here when I say we are doing a lot of work. So first of all, the movement basically has 127 parts.
Unique parts.
Unique
so it's
parts.
140
140
parts,
parts because there's screws and stuff double. On the dial side, we have the back side kind of, which we talked about. So it's not just a disc, it's 14 parts.
Yeah.
Then
bearing and force relief spring.
Then the case also has 20 parts, which need to be laid out, designed, everything checked, you know. Then I asked Ben, he didn't know 100%, but he said roughly 100 components are the PCB, the motor controller, which we see later.
Yep.
There's 100 components we need to specify. They need to be sourced. They need to be put on the PCB. And then I asked this question, you know, I mean, dear software developers, the pros, don't beat me for that. Good code is slim code, I know that. But to get an idea of what we are talking about when we talk software, we are talking in the firmware alone, 9,000 lines of code, which have to be written. We are talking on the app and backend side, because you have an app and you have a backend, we need both. We are talking 25,000 lines of code plus 7,000 for this backend management. And we are talking about a specific backend and backside for managing MicroReg unique watch data, which is also roughly 12,000 lines of code plus another 5,000 lines of code. And all of that wouldn't really work because we have spent more than 10 years of building Brand Cloud, which has, for some people who know what a user story is, plus 900 top-level user stories. So, to be honest, I don't think that just someone comes around and says, okay, I will do that. Easy, no problem. Ultimately, we have decided to do all this in-house. And we accept the pure layout of the PCB. Everything is done in our facility by our people with our knowledge, and the knowledge which was not there has been acquired in the last 2 years to do that. So I would say, okay, that's a pretty serious exercise. And that also shows the speed we are developing. And, you know, when you look at all of that, a lot of things can go wrong. We are, you know, no fortune tellers. We just do our best. And I apologize if something goes wrong. We try to predict as good as we can, but this amount of components with thousands of processes, failure can happen. And yeah, that's the thing we try to avoid, but we also don't have to be naive. And I wanted to show that so that people get a little bit of an idea how much work goes into something like this and how much knowledge is involved into that and how much debugging, finding mistakes, improving producibility, improving robustness of software. Also, it's not just the hardware, the mechanical part, it's also, when you plug in that thing, you want to make sure that it works. And when you unplug it in the wrong time, then you actually want to make sure that there's fallback screens and solutions and all these kind of things so that the phone doesn't hang up. Yeah. Okay, so just to give an idea on that, I would jump then into the next things, which is basically part of this actuation. And this is insane. That's one part of this magic, it's this actuator device. It's three pieces, four.
Five.
This is
All to
5 total with the isolator.
One, 5 pieces, but 2 of them are the same. It's crystals.
Yeah.
Yeah. So just to look at that, that's a stainless steel plate. That is a piezo crystal. That is a peak isolator because we don't want to have a short. And that is the conductive plate, which connects to the case just by assembling without welding or anything.
On the bottom side, there is a second piezo crystal.
Because the power needs to go through the crystal from 90 degrees vertical. And this means that thing will vibrate with 500 kilohertz roughly in height. And this height will deform this material in order to move a screw backwards or forwards. It's brilliant, I mean, someone said sexy. Yeah, it is sexy. It's mechanical in its most sexy form.
Yeah, and also important, no batteries, no internal power source,
no electronics,
no microchips,
nothing.
no electronics, nothing that can deprecate.
Actually,
It's all.
You can, in fact, you can also take out that thing and regulate the watch by hand,
or leave it in and still
or leave it
regulate
in.
by
I mean,
hand.
it doesn't matter. It's still a mechanical watch.
I think a very important thing to say here is this K2 caliber. It's our K2 caliber. This technology is an enhancement that's been added to the caliber. If, for example, all of the technology disappeared overnight, any watchmaker who understands what they're doing can open the watch and can regulate the movement like you would do any other mechanical movement. This is something that comes along that allows you to make very fine micro adjustments to an already well-regulated watch, but it can be regulated like normal. It's not like other systems that deprecate the existing technology, and therefore if they go wrong, you maybe have a problem. This one doesn't lock you into a system that means that you are completely reliant on HORAGE, for example. What this means is you have this extra icing on the cake, so to speak, that allows you to make these very fine adjustments, and you can regulate your watch without going inside it. But if you have to, it can all be done in the traditional fashion. I think that's a very important point to get across.
We are getting another dimension here now. People have recognized that Ronda has launched R01, a new movement, one of the best movements in the OEM space, in my opinion. People know that we have been involved in that. And even more interesting is that I assume, as far as I can see, you can actually exchange that regulating unit.
A lot of the parts.
Yeah, because it was derived from that basic architecture.
Technology stack.
And so, having said that, I mean, we don't want to die, as a company, but companies also die out of whatever reasons, and watches don't die just like that. So they continue to exist. And in that case, there's now another company which has a similar technology stack, which actually, in the worst case, if you break a spring or whatever, because some people always say, it's crazy and silicon and nobody can do that. I don't think so. First of all, I think there will be some silicon fabs doing replacement parts for watches in future. So it will be probably more easy to get parts like that than traditional parts. Second of all, our standard is slowly moving into other companies, and they are using that, which means it makes it much more robust from market point of view for us.
Yep.
In case we do not continue to exist, we always need to consider things like this. Yeah. So very, very interesting times for us, I have to say. And I
Yep.
hope, this Ronda will be very successful with this movement, because I think it's worth it. It was a lot of work, and hopefully they sell millions of that, making a great success of some of our prior work, which also happens to be in this MicroReg watch, because it is a K2 based caliber. Imagine you make MicroReg and you have to start developing a movement first. Forget it. Just forget it. I mean, you would have to learn doing that for 10 years first. And then while doing all of these problems, you also have to learn making MicroReg and have to learn doing software. So I'm deeply relaxed when it comes to, okay, everybody will copy that. Yeah.
Yep.
Try. See you
Good
in
luck.
10 years. Good luck.
Yes.
By the way, we have
So-
a patent, you know.
Next one, Andy.
Okay, so we continue. Dave, you are good?
Yes. Carry on.
Okay, so next slide. Next slide. I just wanted to show that. By the way, that's a pen, a ball pen.
That's the tip
to
of a
see that in the
ballpoint
front.
pen.
That's
Pretty
the
small.
tip of a ballpoint pen. So you can imagine how crazy small that thing is. And that
Yeah.
is actually a really, how to say, this is
Intricate.
a really tricky part. That
Yeah.
is one of the parts. Silvan, we do that with stomachs, I think.
Yeah, it's not
Solotron.
clear yet if they can do that in the right time. But
Yeah.
yeah, it's the part which currently is the hardest to find the way that we get it.
And to be honest, I'm not surprised, because it's
It's
a
such-
punch piece. It
Yeah.
has a dent in order to make sure that when you brace this contact into this piezo crystal, that the load, we have this in English,
Solder.
the soldering actually distributes
Holds.
properly,
Yeah.
holds properly, and that the power really goes through that thing where it should go through. Crazy parts, 3-dimensional, punching, forming, bending.
It's a material
And
with a
in this
thickness of
size.
0.05 millimeters. 0.05.
Yeah.
Yeah.
It's thin.
Not
Massive.
0.5,
Usual
0.05.
Yeah.
We're into human hair thickness territory.
standard. Lower actually.
Yeah.
The
Lower
human
than
hair is
that.
a tenth roughly.
You know,
nothing.
whenever I made these slides, I was fascinated by myself all the time. It's unbelievable. This kind of thing is so small and so
Yep.
delicate. But at the same time, it should be robust. I mean, I expect you drop the watch from I don't know how far away onto a floor, and it should continue to work. We have done that also. We have destroyed a lot of watches. That's Cedric's job. So yeah, exciting
Yep.
stuff. Tough and it bends, yeah.
Yeah,
Next
correct.
part, that was also showing that in combination with an isolator. You know, everything looks so big, but imagine it's nothing. This is so small that you hardly can see that with a bare eye.
When you see it in person, it's completely different. Even with the picture, you cannot really imagine how tiny those things
It actually
are.
is.
It's,
Yeah.
That's a micro-injection
Ridiculous.
molding part,
Yeah.
made of PEEK, which is
It's
pretty
a very
rigid.
good,
Very good material.
plastic.
By the way, the
also
first samples we made in
durability,
3D printing.
Yep,
Yeah.
exactly.
It's
3D
even
printing, yeah,
it's even possible to print those parts
stuff like
in
that.
3D. That's crazy.
So thanks for
Next.
I love you guys grounded engineering mindset. Yes, we try to be as grounded as we can.
And we
Apart
definitely
from
need to be
doing crazy
grounded.
stuff like that.
Well, we know we need to be very grounded on this to make sure it works.
Yeah. Next slide. Let's have a look. Where did we come from? I mean, most people always saw this wire hanging out there, and now it looks very, very clean. Yeah, and keep in mind,
Yep.
it's small. It just will come back to that again. It sits somewhere underneath that thing here.
Can
Yep,
actually
I think your
see
finger's a
the-
bit too big. There we go.
underneath there somewhere.
You can see
there
the
is,
piezo crystal. That's
yeah, a little
here
bit
is
of
the
that.
this one is the yellow part here, and there is actually still a wire soldered to it.
Do we want
So
to
Yeah.
here the
again?
contact is missing, and
Mm.
I don't know if it's
Yeah.
here also. So
Yeah.
the contacts are in those samples currently not yet in.
Yeah, that's
So
wire.
hair thin wire that's connecting. it.
Francesco's welding performance is amazing.
Yeah.
Okay,
he also
Definitely got
has
the delicate
much
touch.
thicker
let's
skills.
continue because we have some dangerous stuff coming up afterwards where we have to do motor controller stuff live here on the screen, and I hope the computer doesn't
Yes.
explode. Yeah, it looks now that's a clean thing. And why did we do it like this? You know, a watchmaker should be able to disassemble that with a screwdriver
Yeah.
and take it out.
I mean, soldering anything in was just never an option,
Never a
because
go.
that
Nope.
is just the absolute death for the assembly in house already. But then if you need to service it somewhere and the watchmaker needs to solder something out, it's no way.
No. That's a
Never.
unit,
Nope.
and you plug it in,
Yeah.
and
It's-
you fix the
Correct.
screw, and that's it.
It's
By the
using
way,
traditional watchmaking techniques that any trained watchmaker would be familiar with.
mm,
Yeah.
here you see the difference of the color. Before it was green and here is blue. And it's the same color. So don't be surprised that it is blue. Just
Yeah, the color of the
changing
movement
between
is,
green and blue.
I think
It's
the
a
best
cool
way to
color.
describe it is iridescent. It kind of changes in the light between a fairly significant blue and in a fairly significant green. That's why we call it peacock.
Good. So next slide. There's some crazy stuff coming up which nobody expected. It
Yeah.
was the wobbling.
A highly
wobbling
technical
part.
term, that, by the way.
Yeah, it's very technical, and everybody scratched his head and said,
No,
we are
I
having a
thought that
problem
cannot
here.
be.
Yeah.
Yeah.
This was something nobody really expected,
Yeah.
Yeah.
until we were empowered by Ben's and Francesco's algorithm art to listen to our watches so
Yeah.
precisely that we actually figure out that there must be something wrong.
Well, I was not
And,
surprised that it moves. I was surprised
Yeah.
that the impact to the data rate was so
It's
big.
crazy.
That was what
Yeah.
I
Yeah.
was surprised.
So I'm going to the next slide. So having said that, this guy here, what's the name of that?
It's a Rücker.
The Rücke in English,
Um,
index or
The regulator.
or-
oh, yeah, I think it's
Regulator.
the index.
It's a fixing regulator, yeah.
So that thing goes along that spring here, yeah, and it has a very small gap where you put through that spring, and
Yeah.
the smaller you want to have that, the more precise the whole exercise is. Yes, we are talking free sprung versus index, but at the end of the day, we are using both. And by the way, the relevant part is not being cool on just doing free sprung. The relevant part is being cool on the wrist running at 0. That is the main point we are talking about. But there's a little challenge coming with that, and that is hysteresis, is it called?
Yeah.
Hysteresis.
Me as the non-engineer in the party here had also to learn something about that, which basically says when you move that way, you create a different curve than when you move backwards,
Mhm.
Yeah.
which is an issue. And the issue is pretty serious because the issue is up to 5 seconds.
It was a lot.
It was a lot,
was-
you know.
It was
I mean,
even
you
more, I
s-
think.
you-
Problematic amount.
or even more than you think, okay, you are adjusting a second that way, and when you go backwards, you're getting 5 seconds the other way. So it's a brutal problem, and somehow with some tricks, you managed to.
Yeah, it's. I even see my sketch down there that
Yeah.
somebody fished out of the chat.
Oh.
My highly professional engineering
I
sketch.
can
with the
make
split bearing.
Dave go away. So now Dave is gone away. So we have
I'm
that's
still
your
here.
engineering
Yeah.
sketch. It's as good as your picture in all of your chats.
Yes, it's I'm a natural.
So
in
that
drawing.
means actually this thing doesn't move out of the center, and we needed very defined actually positions in order to squeeze it to one side.
Yeah.
And then all of a sudden we are using our laser and did some laser exercise, and we figured out that this works. And here you can see, thumbs down. That's what we don't want. We have this deviation from the ideal center line. And that is the result after our modification. I bring back Dave because we don't want to lose him. So that was pretty much, a serious exercise, and it helped us to understand what really happens in this area where the spring goes through actually that index regulator gap and how that whole system moves. And we are talking small stuff. Yeah, I mean, we are talking 0.002.
It was
plus
tiny
minus.
amount of movement, but
So that's
still.
0.002 of a millimeter into one direction. Out of a sudden creates up to 5 seconds deviation. Problem, I think.
Yep.
But luckily a solvable one.
Luckily a solvable. Right? That's what I say. I mean, why am I so confident that we can do all of this? Because we are not in research. We are in engineering, and engineering is a problem-solving exercise. And mostly engineers can solve problems. And the harder they are, the better it is. Well,
and it also helps that we have a engineering team that have a can-do approach to things as opposed to can't do it.
Yeah.
They like to,
Marcus,
especially Marcus.
How long do you need?
Yeah, Marcus, by the time you've asked him how long he needs, he's usually learnt it, which is very annoying. But we will catch him out one day. The only thing I have to say is, though, that he should definitely maintain his day job as an engineer, because I don't think the art world is going to be calling him anytime soon.
I would call it modern or even postmodern, but we can disagree on that.
I'll go for conceptual. We'll go for conceptual art. It's conceiving that it may be art at some point.
We can meet in the middle.
It sounds reasonable.
So
Next.
that was a really hard problem, and this was only solvable because we actually invested so much time, specifically Ben and Francesco, into writing a complete algorithm set to listen to our watches. We basically had to rewrite the standard sound measurement equipment of the Swiss watch industry.
Timescale.
The timescale.
Yeah.
That's what you usually buy from a company, Vici or some other companies.
AliExpress.
Or AliExpress. Known algorithm sets, and they brought it to the next level, I would say. And we see later we will see also some stuff on that. Super interesting. Then another problem which was coming along with us over time, thing got stuck. That's why I have a little tool here, and I brought it with me in a Swiss knife. Then when I'm traveling and I forgot to stop operating the actuator, then I was going too far to that side or too far to that side, and all of a sudden the whole thing got stuck. But that
only in one direction.
Only in one direction. Yeah, it was only in one direction. That's correct. But it got stuck, and we didn't know how to unstuck it unless you open that watch. I mean, having said that, also is important to understand the software will not allow you to do too big of steps, because first of all, it's not needed. I mean, the biggest problem is, I think a lot of people will just want to play around with that watch. And because it's so fascinating when you see that time's going up and down, time out of a sudden is getting visible and tangible, and you can tweak it by yourself. It's crazy. And so we needed to make sure that in the worst case, it doesn't really get stuck, and we don't have to open the watch all the time. So that also solved the thing. Then let's go to the next chapter, making actuators. Those actuators don't fall out of the sky. They have been conceptualized, developed over 20 years by these people, specifically now, Ben and Francesco, and before the team at Miniswys around Elmar Mock. And usually they bought them somewhere from a supplier. Then, since we are a pretty good assembly company, and since we know how to source stuff, I said, guys, let's do that in-house. Can you please set up a process and manufacturing processes in order to do that? And that's what you see here. So basically, that's a batch of 8 actuators positioned on a stainless steel plate with a femtosecond laser cut out and then applied, already glued on top these crystals which we need in order to make that thing vibrate. But that's not enough, you know. I mean, we also need to make sure, does it work? So Francesco and Ben built a complete test equipment tool in order to test these actuators after they have been batch produced. So we are talking large scale beginning production already. And including the software, you know, I mean, you also need to write software and the indicator, and says, every actuator is okay before we actually put it into the next assembly process.
Yep.
So crazy stuff. Batch testing machine, producing that. I mean, we probably might wire cut that thing in a pack down the road, and if there's more quantity coming, then you probably transfer stamp it. But anyway, you can probably pile up 20, 30 or 50 of these sheets and wire cut it with a GF precision wire cut or a FANUC and bring down the cost significantly. I mean, we don't need to talk about cost here right now. Yeah, we anyhow don't earn anything with that watch at the moment. And my prediction was that we probably, in order to industrialize that at scale, is between 10 and 15 million, and Elmar Mock out of the gate said, if you are going to do that, it's into successful quantity, then you need to 20 to 25 million. So let's see who is right. Of course, Elmar has a little bit more experience with projects at scale, but I think we probably can make it for a little bit less than that. Good.
We have
cool
history.
Stuff here. Extremely cool stuff. Next slide. Yeah, and all of that stuff will not be able to be actuated when there is a lot of backend happening. And Francesco thinking very hard in order to make the backend database where all the watches need to be listed, and how do we actually save motor characteristics, because we have to be clear, you know, every motor, we are talking microns, is a little bit different, has a little bit different characteristics, and that's what we try to capture also in the backend and manage that. And when you plug in your phone, then you will be able to actually get the right data out of that. So it's a big job. Just to see lots of codes of line. We talked about that before. Then another person here, Marcus, I make myself go away quickly. That you see, there's another Marcus there. Ben coding more than 9,000 lines, by the way. I made another mistake for that firmware, and Marcus assisting him and entertaining him so that it doesn't get boring. Also important, I would say. Of course,
humor is always needed to get us through a day.
Yes. And talking hard on how much AI can help us to do a lot of things. So that was I listened to that conversation with my left and right ear at the same time. So that was super interesting. So he has a ton of work to do, you know. I mean, 2 months, next 2 months is a stable firmware loader. Yeah, that is the first and most important thing when you make software, especially on hardware, software for hardware, is can you update that stuff, because we are not perfect from the beginning, and it's very important that you can update stuff. Some car manufacturers didn't get that right, I remember.
A lot, actually. Yes.
And you have to come for a software update to the garage. And that is exactly when probably the firmware loader is not as stable as you want that. So here we have this. This is the core robustness setup, all kind of things. Several features need to be improved. Sound management, yeah, we are listening to our watches. So there's a lot of things to get done. We need to source all these components, which are pretty much all of them in order right now, but we need to also monitor when they come. So lots of work to do. And I think that is what I wanted to say about the two guys here. Then we enter in a little bit also into a blend of Silvan's territory with this device. 100,000 versions later in Onshape, finally made it into a 3D printed nice little object with the right material, with the right surface finish, with the right company. By the way, thanks to Materialize. It's a 3D printing company located in Belgium. was recommended to us by someone who is actually supporting Barrel Hand. You probably know that brand. They're making a space watch. You know, I want to do a little bit promotion for the people who do cool stuff. So that they helped us a lot to get around tools where we actually injection mold that, and 3D printing has become incredibly good in quality. We are surprised by ourselves. And yeah, I think Silvan, you tested several materials.
Yeah, several materials, several processes, technologies, and yeah, at the end we end up with MJF, that's the 3D printing technology, which looks pretty similar, like injection molded. It's a picture which you see between Marcus and Dave. Yeah, it's a very good quality.
And I forgot one slide, by the way, but I can quickly dig that out, I think. You also made a tool. Not only Francesco is building tools, also Silva is building tools to effectively assemble on a round transfer assembly infrastructure. Yeah, to set the nuts and all these kind of things, hold it in order to assemble that thing, because it's not just enough to build the tool itself. You need to put it together, and in our case, we need to put together as quickly as possible more than 300 of them, because people are waiting for that. So all of that needs to be done. I think that's also interesting to have a look. So that how does it look from the other side? Where is my I made a mistake here. Not good.
Andy's hunting for his displays again.
Yeah.
But yes, this tool has been, you know, a development. The very original, back in the early days when we announced it, the tool has kind of gone through many different revisions and styles, albeit I think they're all still fairly similar to the original conception idea. But yes, the tool is now up and running, because we also had to factor in the usability of the tool, and we didn't want it to have to be so delicate that you were very careful about how you put the watch in. I think from using it myself, it's very easy now to put a watch into the tool. It's fairly bulletproof and fairly easy to get the watch in the right location.
It feels nice if you
Yeah.
actuate it. It's actually a very good,
that's what we're going to do now.
Feeling.
I think we are moving on to the next thing. I want to talk also to a remote team, which is a lot of work. It's our Taiwan team, 8 people sitting there. I mean, I took CC out for snowboarding. She was a little bit scared, but she did well on Schildhorn, my personal living room. And then they also got a good cheese fondue on a bread, you know, raclette, and a nice sausage and some good view. And they are actually making this app, which I'm going to show you now. The first thing, that's what I'm showing you. They also are involved, obviously, in a lot of back-end exercises. So here you see Andi test. Marcus might activate later that phone, which has a test app on it. But she also made a demo for the screen for me, and I'm going to show you that now. So just to come over here. So good.
There we go.
So basically, that is what also happens on that phone. You can basically, Marcus, we could do that. Can you plug in that electronics?
This one here.
Yeah, that is a test electronics, but it's basically the same thing. Yeah.
It's the same thing, which is later in the actual device, but it's just the first.
It has the same components, a little bit less components, because we added some stuff, as far as I know. But
this way.
Yeah, let's just put it there. People want to see it, Marcus.
Oh. And this is us live showing you how the tool will work.
Serial number. You need to type in that serial number, and I can tell you what that serial number is. It is Andi test, groß in big letters, capital letter, all big, yeah. Andi test.
So in the
One.
when you are adjusting your own watch, you don't need to put in the serial number every time. This
No.
is just because
No.
it's the guest
A
mode
test.
you're running.
Yeah.
So not that you mean that or think that you need to
No.
put
Yeah.
that always inside.
Please bear in mind,
Yeah.
much of the stuff you're seeing
Oh,
on this
no.
live is development PCs, development prototypes, etc. So it's not as the final will be. The final user interface will be very easy and clean to use.
Mm-hmm. Did you can actually log in.
Well, I don't have the login.
No.
We are
so you
very,
just
very well
continue to
prepared.
talk.
So Dave to the rescue.
Dave to the rescue. Dave, start talking, Dave. Talk,
is
Dave.
talking about shipping. Dave is talking about shipping.
Well, actually,
Okay.
yeah, why don't you pull up that slide whilst you guys have a
Yeah.
display? Because I think it's towards
Good.
the
I
end.
can-
There
I
we
can-
go.
I
So
can.
many people have been asking about it. Now, we have around 300 pre-orders at the moment, and as hardworking as we are and as magic as we are, we can't produce 300 watches all at the same time. So we, of course, have to work a way to produce these in batches that allow us to efficiently get through as many of the deliveries as possible. Now, we've always said that deliveries will commence, i.e. start, at the late summer 2026 period, and we are effectively on schedule for that. Now, what we're going to do is we're going to be splitting it into kind of 4 batches or tranches of watches, with each batch being 75 watches. So, of course, that is 4 times 75 gets us to our 300. So where we're at the moment is we're looking at the first batch will start to ship in mid to late October. The next batch will be around mid-November. The third batch will be late November, early December. And the final batch will be in mid-December. So depending, of course, where you placed your pre-order will depend on which batch you're in. The first 75 people that placed orders from the very start, they will get their orders in that first batch, and then we'll work through. Now I can give, because I actually managed to pull all the data out of our system so that I could give some rough dates. Now, effectively, if you placed your order from the 19th of September, if you placed your order up to the 19th of September 2024, that'll put you into batch 1. If you placed your order from the 22nd of September through to the 24th of February 25, you'll be in the batch 2. If you place between 25th of February 25 and the 5th of August 25, you'll be in batch 3. And if you placed your order from the 11th of August 25 to today, you will be in batch 4. That takes us to, I believe, 2 watches shy of 300. And of course, we are still seeing people placing pre-orders. So there are 2 places left for that final batch of 4. So batch 4. And then any other deliveries after that will likely be towards the very end of 2026 into early 2027 for deliveries of newest orders. But as it stands now, everyone who has placed a pre-order with us from the very start of this right up to today will have their watches delivered by Christmas. And we had a long meeting with all of the production staff and everyone in charge of that to ensure that we believe that's all deliverable, and everyone is confident, fully confident, that that is maintainable. Of course, there's always the caveat, if something goes terribly wrong, touch wood, nothing goes wrong, then that may change the timelines. But as it stands, we're feeling confident that that is definitely deliverable. So we are really pleased to say that we are looking to be effectively on time and delivering within the window that we were hoping to. If any of you have got an order in, hopefully by your order date, you should be able to work out roughly which batch you're in. If not, of course, you can drop us a message either via our WhatsApp channel or, of course, by email, and you can drop us a message with your order number and or name, and we can give you a clearer idea of exactly which batch you're going to be in. So yes, lots of work has gone into this. We'll see all of the fruits of these, multiple years of development come to the fore, with people having watches in their hands in the very near future. We're in that home run just now. Lots of parts of the watches are in production. Movement parts in production, cases are in production. In fact, I think even the bracelets and straps have arrived already. So many of the parts are ready to go. And it's really the big push is on the tool and the software now to really get those over the line and finished. So that gives hopefully all of you a bit of a feel for where the kind of deliveries and shipping should be. Please note that the minute that we start to ship watches, the watch will go up to its full and final retail price. As many of you will know, we've been offering an extremely subsidized pre-order price. That is still available. So anybody who has maybe been thinking about it, considering it, maybe after watching this live, it's made your mind up that you want to move forward with an order, that would be your opportunity over the next couple of months to get your pre-order in if you want to catch the watch at that amazing price, which is currently
every 1.5
$4,750.
day, there's an order, Dave.
Yeah,
Every
I mean,
1.5 day, consistently, kind
pretty
of
much.
people
Yeah.
buy this product, and we are seeing increased speed because people recognize that this is going to be the fourth force in chronometry watchmaking. I will talk about the other three in another live because I made up my mind. And yeah, we want to be the new force into that, redefining what chronometry can be, namely something made for humans, for the wearer.
Indeed.
Okay,
well,
so
a couple of folk have asked, a couple of quick questions, Andy. So someone's asked, they're in the first 75, can they pick it up at Wind Up New York? Definitely drop us a message. We will see what is possible. Wind Up New York is mid-October, so it might be just fractionally tight to do that, but do drop us a message, and of course, if we can work something out, we will do that for you. And someone's asked, is it possible for a local pickup? Absolutely. If you want to come to Beale and pick your watch up, just make sure you'll let us know, because by default, it would be shipped to the address that you left on your order. But if you're looking to pick it up in Beale, we can absolutely make arrangements for that. We just need to know what day and time you would like to come so that we can get that into our diaries. So yes, any questions about deliveries, drop us a WhatsApp or drop us an email and we will get back to you with details.
So let's have a further look on our presentation thing. So I actually logged into that app. There are two ways. You can do that without logging in and just use the standard, and there is a way of logging in. CC actually put that Andi test one watch into our test database, and it's now assigned with my email account where I bought that watch. That means this app will not only be for MicroReg users in future, it will be for every watch owner of HORAGE watch. And I hope we can do other cool stuff with it. Dear HORAGE, help me, your watch is broken. And then you talk to your app, and then Silver will crawl through that app into your place and help solve the problems. That's my dream here. Beaming. Okay, enough bullshit here. Okay, sorry. Let me. Oh, I'm in the wrong. Oh, sorry. I'm in the wrong thing here now. The people didn't see that.
People can see it.
Here we go. So that big electronic thing is effectively the same like you saw it before. The small one now just repackaged to fit into our device. We will show that this is true because we also have another live demo with the other app which Francesco set up for me. But basically, you see the workflow here, successful login. The login is usually done with a one-time login via email. I can show you that also. Just during that live show, I logged in and I got that thing.
We're hearing Andy. Some folk are saying your sound's not very good, Andy.
My sound's not good.
Apparently, a few folk are saying they cannot hear you very well.
Cannot hear, then I need to talk more loudly. Yeah, I see that's a little bit quiet, Marcus. We have problems. There's some issue there. Is it you? No. But Marcus was okay, huh?
Am I better? Yeah. Oh, I'm also quite.
You are also lower than
quite low.
Is it better now, or?
If someone can let us know. Well, Franco in the back end says Andy sounds good to me. So we've got someone else listening in the channel from our side, and he says Andy sounds okay. So that's good news.
Magic Franco.
Yeah.
In Austria, the sound is always more.
we get beautiful Austrian mountain Tyrolean sounds.
Yeah, good. So let me just continue, and if we have a sound problem, then we have it. We cannot change that right now. But let's continue doing this kind of thing here. yeah, what is that? This is this sample PCB, which has a lot of electronic components on there. In order to test what we want to do, then you actually press this thing here. Then you press adjust. Then it says, okay, watch detected. And then you can continue doing something like this here. And you can do that slower and faster. So that was the latest, or that was the latest test app. But there's the next release, which I'm also going to show you now. That is basically the, wait a second, this one. So that is the next step of that sample which you saw on the phone. It's just not yet released on the server. So I'm operating that for you. You see there's a lot of changes from what you have seen before. And there's a track and an adjust button. So adjust, it says, okay, I'm connecting to the device. I want to see if there's a watch. So that is actually what we are doing right now here. And then we are suggesting, okay, step by step, don't do too many adjustments in the beginning, because we want to make sure that you don't over adjust, or you can select manually or faster and slower. So these are the two different things we can do. Then let's do that. So then we are adjusting, you would say plus 0.2 seconds per day. And then the device says, congratulations, the thing has been done. And we close that again. And we also have a tracking function in there to see basically what is going on. And you have a current run and a new run. So you can continuously track what you are doing with that watch. And when the watch has been stopped, then you need to obviously probably start a new run, because out of whatever reason you didn't wear it for a while, and so on and so on. And otherwise it doesn't make sense to continue with a interrupted measurement process. So that is important also for us to learn something about what's going on in these watches, and also for yourself in order to get a good feeling for that, because it's super fascinating. And I hope down the road we are going to have other cool functions, probably more visual functions, to see what that watch is actually doing. And I would like to show that also, because Francesco built a desktop version for our internal use, which we showed partly on the EPHJ to the people.
Perhaps let me quickly explain why this tracking is important.
Yeah.
Because for me it is important to explain that.
Yeah. Wait a second. I need to go back to the screen.
Yeah.
So
a question actually that is worth talking about whilst we're on the app is, someone has actually asked quite early on, will we, or are we planning on allowing controller access through an API? He's asking because about long-term support and the possibility that maybe a mobile app can eventually stop being maintained and might stop to work. He would feel better knowing, are we planning to give controller access through the API? So that's a question we can come up with at some point to answer during this next section.
So why is tracking the accuracy important? We need to, or every user need to create an average of how precise the watch is running through, let's say, 10 days. And then after these 10 days of tracking your watch and calculating, well, the app calculates the average of the daily rate, you can then get this number of, let's say, 1.2 seconds too fast. That's the average overall these 10 days. And this value, this 1.2 seconds, you correct. So you cannot adhere to the watch in a static position, dial side up, because this is not the average which you get when you wear
what you create. Yeah, correct. So the wearer influence is the relevant. You could figure that out with any tracking app. Yeah, but we have put a function in there to keep track of that.
Yeah, and to automate then the adjustment.
Yeah. Good. Yeah, cool stuff. So
very much
thanks to Taiwan for making that all of these user interfaces and thinking hard of how to make it workable. You know, in the beginning, I still have the discussions in my back head of what we were dreaming of, and then we were building samples. Shit, nobody understands that. So it was really, that's the hard part on software, you know, you're dreaming up some functions and then you figure out that actually nobody understands it. So user story design, where is the button? Is it in the right size? Does it actually tell the right thing, what you should do? Is the wording correct? Is the size correct? And then you change this 100,000 times. And I could bring up this Figma backend to see you, but we are running out of time. So
actually, on that one, Sylvan, someone asks, AW Labs is asking, we decided against including a listener in the dock because it would only track in one position. So that's not technically true because there is a microphone in the dock, correct?
There is a microphone inside, out of several reasons. One reason is to detect is there a watch actually. That's one reason, and perhaps we can use it as well in the future for other features.
Yeah.
But we need more experience.
Yeah,
correct.
First. Yeah.
I think it's fair to say that the app will deliver initially everything that we've promised, but we've since found out that there's probably lots of opportunity of cool things that we can do over time to develop the kind of ecosystem and the infrastructure.
Yeah.
So I think having said that, I would like to demo that other thing, which I think is pretty cool. So we are on track with that app. It will have, you know, software is never finished, by the way. That's why updatability is so important. Any CEO who thinks you make a software project and then you get a finished product doesn't understand software. That's the sad nature of it. It's a constant evolution and a constant improvement, and it will start at some point and it will never stop again. So when you want to build software, be aware of that. And we are very well aware of that because some of our people, including myself, have 25 years of experience with making software and running software companies besides making watches. But now let's have a look at what Francesco provided me today. And I hope my computer and the whole live stream doesn't crash. We will see now. He installed actually an application to run that device. Marcus, can you please change now from here to that other thing? So that is basically the device, which is USB-C connected. It is now the same electronics, just in the small device as it should be.
This, to give you an idea, is very close to what the pre-order customers will be receiving in regards to the tool. The microphone is in the little area to the right of the crown.
Yeah, and the silver line there.
As big as I can, because I need to see where the regulator is. The watch which we have on display is running, as far as I know, a little bit slow. And I will not adjust it to the full thing because that's why we have the regulator screws in order to set it into the middle when we ship the watches. But as I said, it's a lot of demo work here. So I'm now opening a specific device, an application on my computer, which then should actually open another cockpit here, which is pretty cool. And it is another microphone here, detected, allow. I hope my other microphone doesn't hang up, or the rest of the whole computer system doesn't fall apart, because I didn't test it in live mode. And now we are seeing actually a control app in order to control and generate the signal, which can then adjust the whole device. And I need to select that here. So Francesco said 61.
There's a Miniswys.
Miniswys
sounds good.
No, but I need a 61. Oh, do you see 61?
Nope.
Why is there a 62?
There's also 70 and a 66. So.
That
and
is
the test is on.
problem.
Why don't you try that one?
You cannot scroll through?
Yeah.
No, there's not
Possibly
more.
because there's lots of microphones currently attached to Andy's computer.
Yeah.
I think this one, huh?
Just try it. Nope.
Not that one.
Well, not that one. Eh?
The device is
Francesco.
connected.
Yeah, device is connected. Yeah.
Yeah.
Maybe disconnected and reconnected and see if another one, because now sure it's not this
And
one.
we're,
Yeah, that's this one. It's the one that's called Miniswys.
Okay.
yeah,
It's
should be
what a
Change the
Miniswys.
surprise.
Okay, so I mean, you know, we are in unknown territory here. So I start the whole thing. Open MicroReg controls.
Yep, shoot.
Then I need to actually I
Set
need to
these.
make myself go away quickly. Read. Yeah, shit. Kannst du das eingeben, Markus?
Ja.
580.
Ja, vielleicht
Yep,
ist die
correct.
Tastatur.
580.
Then you press set, Andy,
Yeah, set. And
on the
other
adjustment
one
frequency.
was
Activate.
730.
Pardon
set,
the
and the others is
the little
2000.
gap in transmission at the moment whilst Andy is setting this up. We are working through it. Any other questions that
Okay.
anyone wants to throw into the chat, please do so as we are doing this, because we are now, well, we're over the hour, so we have a little bit of time left, but please do put any questions that you've got in and we can, of course, talk
So then we
through
try.
those.
We start the whole
Let's
thing.
try, Andy. Yeah.
You need to switch the screen
Let's
again, I
see.
think.
Yeah. You need to go back to the
Okay.
live screen, Andy.
I am in the live screen.
That's good.
Oh.
There
And
we go.
let's see if we hear something, and we are hearing something.
Oh, we're hearing the
Now-
watch. There we go.
Yeah.
So every
let's see.
line there is a tick.
Yeah.
Yeah.
Tick tack, tick tack.
So that's actually the spectrogram, yeah.
Yep.
And then we have a rate analysis. And I make myself go away again. So you see
There we
here,
go.
that is what's happening. I mean, we are waiting. That is an 8 seconds. So 8.5 seconds average. And we have 14, 40. And the longer you listen, of course, there's no line yet, the more flat the whole thing is. Yeah.
Yeah.
And the shorter you listen, the more deviations you will see.
And what you're looking at here is live data from the watch that Andy's put into the tool.
So if I move it now,
So Marcus is just slightly, and wait, let me.
I think you
shift
can go
into
full screen,
prompter.
Andy,
Yeah.
on one of the. You can go full screen on one of the
Oh.
charts.
Oh, Marcus,
No,
you are
it-
not good. You did
it
destroy
jumped out of the
everything.
device. Everything's broken.
Yeah.
Oh no! Oh, there's exactly where he
Actually-
pinged out the device. You can see that the device has registered the noise.
Yeah. So what you can see here is basically when Marcus is lifting that. I mean, Dave and Silvan, I
Yep.
took you away, yeah. Just
That's
that you
okay.
are aware.
They can still hear us.
But it's crazy, you know. I mean, I can do full screen.
Go full screen, yeah, on the
Yeah,
chart,
full
Andy.
screen, yeah.
That's it.
So now Marcus lifted again a little bit.
Let's see.
Just a little bit. Don't be so harsh.
It now has a huge deviation from when I plopped out the watch.
Yeah.
So, but you can see that it's actually the rate changes a little bit if I lift it. Now I set it back down, and now it's going back to
So it's the blue line which you need to look
Yeah.
up.
Yeah.
the blue line went a little bit down and up again.
So then what we also want to do is we want to do some live adjustment, correct? So don't touch it too
There
hard.
we go.
Going back to, I have my operator thing here. 1 second. I think
Yep.
maybe do a reset quickly. Evaluate reset
Probably.
because you killed it.
I broke it with my button fingers.
We didn't
So
break
let's
it.
see
We
if
we
something
gave
is
it some
coming.
field
No.
testing.
Yeah, so we got some new signals here. Crazy stuff. I like it.
Yeah.
And
There we go.
I'm doing a full screen here again.
Perfect. There we go.
And now, when I now have that, I effectively have the prompter air, and I want to see, you see that? So down is a little bit down. I would then adjust.
You need to maybe move your window, Andy, because you're covering the tool adjustment tool.
It's also not very visible. It's very small, maybe.
Yeah.
Yeah.
So here, like that. Okay, so let's move a little bit up. 2. Do you see something there, Marcus? Yeah.
Yeah. It moved.
1, 2, 3. And surprise, surprise,
Up it goes.
up it goes. From minus whatever it was into close to 0.
And
That's
there
cool.
you can
It's
literally see
insane.
in real world the
Then
adjustment.
it goes a little bit down again, you know, and that's
Settles.
the whole magic behind it. It's an unbelievable cool function.
Yeah.
It settles in. Let's look at it like this. Everybody wants to be here. You know, we are all back together into bending
We're all
time.
back.
It's crazy. Yeah.
And this,
Just-
remember, is
Just
live.
to
This
show
is
you
a this
again,
is
you
a
know.
prototype watch in the prototype tool, having
So we are
adjustments made to it.
-2 now. And when I'm actually lifting that a little, I'm lifting the watch a little bit now. Ooh, I didn't do anything. I just lifted it roughly 30 degrees. So,
Yeah.
which means, and now it's flat again, which means how sensitive is that?
A watch. Yeah.
I-
It shows you
today,
how
you know,
sensitive
it
a watch
really-
is to position.
I really got even more respect from what a watch actually is and how sensible accuracy is. And when that stuff was invented, I don't know, 200 years ago, wristwatch or whatever, a long time ago,
And this
there were no
effect is why we need
computers.
to. This effect is why we need to get the average.
Yes, correct. Because that
You really
happens
see it live.
1,000 times per day, 100,000 times per day over 10 days. And you will see the average, and it's getting much more flat.
Yeah.
When I can actually close that thing, I think. And when we go down here, you know, the longer you measure, then you see it like this. That is a measurement over 60 seconds. So you don't see all this extreme movements.
So the difference is that you get an average over a longer period of time, and that makes it more flat.
Correct.
Yeah.
Yeah, let's go back to this one here. So that's what's happening in 8 seconds average. And we are getting somewhere into 0 territory, yeah?
Yeah.
Still a little, here's the seconds. That's actually the deviation from what we had.
Need to adjust a little bit more.
So I just don't know how far I can go. I don't want to get stuck, you know.
In that direction, you still have.
We still have,
Yeah.
we still have room.
Yeah. There's still
Wait,
some.
I need to change into that
Mhm.
category again. So I can still move it up a little bit.
Yes.
It's your fault when it's stuck.
I will give it to Cedric tomorrow. And
So when Andy
beg
breaks
for
it-
forgiveness.
Luckily, I'm
luckily,
on
we have
holiday.
plenty of people.
So
Yeah.
I
Luckily, we have plenty of people that can solve these problems.
did another 2. So
And up it goes again.
up it goes again. A little bit. Shall I do another one?
Is that something?
You're
Yeah, do
close to
another
zero.
one. You do another one.
Yeah. There we're coming in.
Yeah. It's crazy stuff.
Indeed. As someone said, yeah, AW Labs again,
Yeah.
showing what a watch does.
You know, I told you, we are capable to let
Yep.
a watch run on someone's wrist according to his average on 0. You cannot do this with the best process, traditional, COSC, metas, whatever you want to do. This is not possible with
Yep.
traditional way of chronometry as we know it. I just wanted to have that said.
Yep. Indeed, indeed.
Yeah. We are now
So,
0.5, 0.1, 0.5 above 0.
Yep.
Cool, huh?
Yeah, indeed.
Yeah, I think we are happy now.
We
And
are.
that was a live demo, you know, there was nothing faked here. No
Nope.
recording,
And-
no nothing. It was
And
real.
please bear in mind, we are still dealing with prototype watches, prototype tools, and a system that's still very much in development. But we know that it does what it says on the tin, which is everything that we promised. And there's lots more development that will come along with this product, watch, and complete system as well. Because we're, of course, we never sit still and we're thinking about how can this be applied in the future? Because this is not a one-off watch. It's not a one-off product. This is the Founders Edition. This is the one that brings it into the real world. But of course, we've been thinking about how can we bring this technology into new models, other models that we do. It's lots of exciting things to come over the next 6-12 months.
Good. So I think we are
Good.
going towards the end.
I think we're coming towards the end. Any more slides, Andy?
Computers didn't crash, of course.
Nope.
Our beloved QR
I think
code.
we said we did promise that we would make a couple of updates. So on the watch itself, the
Wait
little
a second.
indicator. Yep. Oh,
Yeah.
there we go. The indicator on the watch, instead of being a red line that will have been seen on many prototypes, will be a yellow triangle. The final color for the time telling disc on the front will be an anthracite grey with white numerals and markers. The inner kind of rehot bezel ring is now in a kind of darker grey with the cutouts on it rather than the silver that was seen on, again, many of the prototypes. That just gives a nice amount of definition against the rest of the watch. The colour stays, the peacock green-blue colour stays. We'll argue all day long about whether it's green or blue. It's both. I think that's the easiest way to say it. And, you know, everything else about the watch is really very much coming together. Tools, again, very much coming towards their final designs, and the software that will be nailed down in the coming weeks. So yes, we are super excited to get these watches into people's hands and on their wrists, because it is great fun. I mean, you know, whether you are super obsessed by regulation or not so obsessed by it, it's good fun. It's great to put it in a tool and make adjustments in a safe manner. A lot safer, certainly, than opening the watch up and thinking, what can I do with this screwdriver, which usually ends in tears before bedtime. But yes, this will be fun and games. So we're, I think all the guys, I think Sylvan and all of the other team are going to be excited to see what people make of this and what they do with it as well. Because we've thought about, we think everything that people might try to do with it, but I'm sure someone will come up with something to do with it.
Sure, I'm 100% sure.
The software question, you know, the API question, I think the best answer is, Andy, you know, everything's up for debate and questioning, and what we do in the future is we will make this as accessible as we can do.
And there's another question. Yeah, so the API stuff. So in general, we are in full control of our servers, our databases. There's nothing we do not control. So we are also in full control of building APIs down the road. But as we all know from software, when you put an API into the world, you need to be 100% sure that everything is okay. And because usually you don't want to touch that, to not create other trouble down the road because you didn't have thought about it enough. So
Correct.
We can do that. Android later. Yes, why Android later? We are a little bit short on Android development capabilities and power. And usually our workflow is that we start developing in iOS and then once the problem is, you know, when you do simultaneous development, everybody knows that, and you're not sure in the first shot, you change 2 systems at the same time. So we first go through iOS, make sure that things are okay, then we move again with Android. And in this way, we avoid lost coding power, which is scarce and valuable, no matter how much Claude AI can help to do that. Still, there must be humans to verify if everything is good and come up with good ideas. So that is something. It's the same with, by the way, USB-C and Lightning for the iOS crowd. We cannot code backwards for a standard which will cease to exist. I'm the lazy guy, you know, Dave. I still didn't change your phone which you sold to me, and this has still a Lightning, and so I cannot use that app. But I will do that. I will do that.
Yes,
also,
you should.
Leo is angry with me. So that's something, okay, that we have to do some trade-offs, because we are not a huge company having a developer force of 10,000 people. We have effectively, including Ben and Francesco and a little bit Marcus, only 11 people then who know something about code. And that is not a lot to pull that off what we have to do.
Yep.
Yeah.
Exactly. But
that's pretty much it. And
it's not a case of
scan that
forgotten.
code.
It's very much a case of work through. Yep.
Yeah.
Then the code, if you want to get in contact with us, that QR code, which is, nope, wrong way, that way. That QR code there. If you scan that, that will get you in contact us via our WhatsApp channels. You can, of course, if you're old school and want to use email, lostintime@horage.com will also get you through to us. You can go to our website and click.
It's not a spam channel, yeah, by the way. It's not about, it's really chat. I rewrote that, by the way, Dave. Chat with us, talk to experts.
Correct.
Because
so
I consider myself to be an expert in that case.
Yeah. The reality is as well, we can definitely not spam you, because you have to instigate the conversations. So don't feel any fear of us going to spam you. We can't do it, because after 24 hours, you have to talk to us before we can talk back. So a super safe and secure system. Email is there, as I mentioned, if you want to, lostintime@horage.com. And of course, check out the website. You can get all the information about our concierge all around the world. We have concierge in the US, in Taiwan, in China, in Germany, in the UK, and we're expanding into other markets. But there are local people on the ground who have our watches and the know-how and the knowledge to talk to you if you want to catch up with them and have a look at any of our products or watches, or even just have a chat with them about MicroReg, for example. So yes, please do check out those guys as well. I think other than that, anything else? Anyone else want to say? I think we've covered all the questions, hopefully. This, of course, will be there.
How to stop streaming now?
We need to all stare at the camera and not say or do anything stupid for about 10 seconds. And apparently that's how we end it properly, or else Leo will be angry again.
Yeah. So we do the staring thing now.
Yes. Thank you very much, everybody. Thanks for joining in. Hope you enjoyed it. We look forward to delivering these watches in the very near future. Thanks very much for listening.